July the 11th, 2016. Quick update on the earlier video. You're looking at Tiangong-1, what the Chinese space station guys that they call the Heavenly Palace. But they never got to complete it as they were adding modules to it, and they wanted to eventually get it as large, if not larger, than the International Space Station by adding these components. But what we're going to talk about in this video is how to track it and how to determine for yourself if this thing is losing altitude. It may take days or whatever, but notice it's approaching the equator on its downward pattern. Now this is this afternoon. I'll put the timestamps up. And if you look at just above the blue bar to the right, this satellite has a period of 93 minutes. That's how long it takes to orbit the planet, moving at 4.77 to 4.78 miles per second. It's doing 4.78 now because it's on a more or less a downward run. Now, as it crosses the equator, it's going to be at its lowest point of the orbit on this downward run, because it's an elliptical orbit. It's not a circle going the same altitude around the planet. And I'll show you a diagram of that. But as we approach it on the downward pattern, or the downward movement of this orbit as we cross the equator, that's when you, if I were going to do it, I would take notes or do a screenshot at the time it crosses the equator. But you can watch to the right the altitude in either kilometers or miles, and what that'll show you is as it crosses the equator, the lowest point. Now it's going to be about 10 miles different in a half pass, in other words when it comes back over the equator, because the map is confusing, but this thing is kind of going over the top of the globe and down under. But I'll show you a diagram of that also. But mark it and you'll see that the miles per hour as it's getting lower will start to slow down the change in the altitude. Notice at 229.23, right in there, we're about to cross the equator on the downward pass. 229.22, everything's starting to slow down, because once it gets at that point, it's going to slow down and speed back up. But the furthest point, the apogee at the top, the perigee at the bottom, and if you were looking at it without that map peeled out, this is what you'd be looking at, guys, right there. Now right now it's showing about a 10-mile difference in the apogee and the perigee. That's again, the apogee at the top is the furthest pass, and you'll see that as it's coming up in just over 45 minutes. You notice again, satellite period 93 minutes, cut that roughly in half, and you'll see it on its upward movement. We'll check it at near the end of the video, and we'll check it on the next pass of this one. I saved them both. This was earlier this afternoon. Notice 229.21 right there, and it had paused at 229.2. That's how many miles high above our planet in the atmosphere that it is in altitude. So at 6:53 p.m. CDT, screenshot it, guys, or just make notes if you're interested in tracking it. Write the time down and that low pass. Now, what I did was, if you look at this, just over 45 minutes later, I copied the second pass, but it was a half pass. Next half pass, 7:38 p.m. And notice it's not quite 10 miles different, so it's not quite as exaggerated as the diagram that I showed you. But what you would want to do is mark that pass too. Or you could check it every 93 minutes and check the low pass of the downward orbit. But that's what you're dealing with, and you'll also see it speed up about a mile per second on that downward pass. Go from, say, 7, you can see now on this downward pass it's 7.69. Now, you'll see both the altitude start to rise and the speed slow as it climbs back up in that orbit again. But there's a footprint on these satellites, and I'll show you a couple of diagrams of that. And there's a breakup point, and you're dealing with about 84 kilometers to 70 kilometers as an average of the breakup altitude. If you put that in the middle at 77 kilometers, you're at 47.84 miles. So from 40 to 50 something miles in altitude, the breakup point. Notice the lowest ballistic coefficient debris and the highest ballistic at where it strikes the ocean, guys, in the bottom, that's the faster moving debris will further travel further. It's called a footprint. But as it hits that atmosphere, it's going to burn the solar panels off. Anything like that, it's going to burn off this satellite. Now, that will increase the speed because you've decreased the drag. You understand what I'm saying? This is not my theory, but these are images of it, and they wanted to get it bigger and bigger. No, that is not Nibiru, guys. Those are sunspots from the sun above it. And people that do Nibiru videos showing these sunspots, guys, you're doing a discredit to the people that are actually researching it. But as it gets down into that 45-mile in altitude range, guys, it'll burn the panels off and it'll start to melt some of these larger objects. Now, we've never had a space station come back into orbit like this. But when it starts to melt the larger objects, it's going to be decreasing in altitude and cooling off. And those molten pieces will reharden. Not all of it. Some of it's going to burn up, like any of your plastics in it, or again, the solar panels. But something that is this heavy, they're saying 8.5 metric tons, and I'm not sure at what point they gave us that measurement. Was it initial launch or after they had added a couple modules? I'm not sure about that. But we're looking at our website, and what we did, we went in and put, since the first video, notice right here, the Tiangong-1 Chinese space station, so you don't have to go to a lot of trouble and put the NORAD numbers in. Just click right there, and it's going to take you to the actual page for this particular space station. Notice, if you've never been there, guys, we've got Eyes on the Sky, the ISS tracker, we've got news, we've got live images from the IS there. In the bottom right, your volcano and earthquake information as it comes in, and the entire left channel is nothing but links for earthquakes. And this top panel, guys, is different solar cameras, different satellites that are watching our sun from different angles. But again, let's just quickly, since I clicked on that link, the new link, to make it easy, this is where we're at. We're just past a downward orbit. It's 229.48 in altitude. Notice that, because it's starting to rise again. Now, because I was doing the video, I did not catch on this last pass that minimum distance. But remember, 93 minutes, if you want to keep notes, just before this thing starts to re-enter, you're going to notice a drastic drop in the altitude on the low passes. At what point it breaks up with that footprint that we saw would determine the impact points. And this is kind of new territory, because at 8.5 metric tons, you're at 18,787 odd pounds. Again, I'm not sure if that was the first section of it and the information that was passed out then, or after they had added some modules. Not sure. But I know they evacuated the astronauts. They have lost radio contact. Again, this is your footprint. You can click that on the map. Notice at the bottom where it says draw footprint. And you wouldn't worry much about the back section of that footprint, in other words, behind the object. But this would help in the forward trajectory of the low ballistic and high ballistic impact points, guys. But we're going to watch it, and you guys watch it too, because it's a lot of information. Someone check it out about every 93 minutes on that low pass coming down. When you start to notice a drop more than just a few feet in that altitude, you know it's starting to drag. And once it starts to drag, it's going to pull it down and start to burn up, burn off those panels, go through its melting phase. As it cools off in the lower atmosphere, it's going to reharden just like molten metal would. And it would be, this is not an earth-changing event. I mean, it depends on where it hits. But the guys, we are watching earth-changing events. Just on the side note, there's a run on the banks in Italy. Now, we watched that with Greece. Just a side note. And Greece was in trouble, and it caused some problems in the EU. But Greece was the 44th largest economy on the planet. Italy is the 8th largest, and the banks are in trouble, and now their prime minister's asked for a $160 billion bail-in to the banks there. This is big in Europe. You had Brexit, now you have this. There's problems coming, guys. Be prepared. It's a heads up. Be safe.